Okay, so for chapter 14, it's about thermodynamics. I think you guys have heard it before, tapi tak pernah apply anything kot. Okay, so if you are looking through the formula sheet yang saya beri last week, saya ada forward one more time. And then this one covered equation 76 until equation 78. Okay, so the equations are Q equals to delta U plus W and so on. Okay, these three is about work. Okay, so work in thermodynamic process. And this one is about the first law of thermodynamics. Okay, you will learn these things soon. Okay, what is thermodynamics? Thermodynamics is study of how energy can be transferred between a gas system and its surrounding. Okay, it study the effects of change of internal energy of the system. So basically, we want to focus on the change of internal energy of the system. So if you guys still remember, U is equals to internal energy. So delta U here represent the change. Okay, kalau delta ni maksudnya perubahan lah. And then how does it affect the pressure, volume and the temperature? Okay, so these three, I think it's very similar with the previous chapter. Kamu ada charge, bonds and G, Z. Okay, you have to apply those information over here as well. Okay, and then kalau kamu lihat over here ada NRT juga, so which is something that you might have to use daripada previous chapter. And then kita ada U. Okay, U ni tak ada specific equation untuk chapter ni, tapi dia pakai equation yang sebelum ni. So you have two methods to calculate U. One is using this first law of thermodynamics. Yeah, another one is by using U equals to F over 2 NKT. Nanti jadi saya tunjuk balik lah. Okay, so first law of thermodynamics is basically about this equation. Okay, Q here is basically heat. Okay, delta U is a change in internal energy, and W here is work. Okay, I'll write down so that you guys don't get confused. This one heat. This one, remember, this is a change in internal energy. Which you can represent by U2 minus U1, perubahan. Okay, and W here is work. Okay, Q tu unit dia apa? You guys remember tak?
Joule.
Joule. Okay, good, very good. Delta U? Internal energy, unit dia apa? Apa dia? Nadira cakap apa? Tak dengar, sorry.
Unit dia K ke?
Unit dia adalah Joule juga untuk delta U. So Q is a type of energy which is heat. That one is in Joule. U pun adalah types of energy. So change in internal energy is basically change in energy lah, Joule lah. And then the work done also in Joule. So you have to remember that. Okay, so Q, delta U and W, all of this is a scalar quantity. So scalar quantity, kalau vector positive and negative represent the direction. But for scalar quantity, positive and negative ada different meaning. In this case, positive Q is basically means that the Q is being absorbed by the system. Okay, when we talk about the system, we're actually talking about the gas. The gas here represent the system, enclosed system lah. Kalau yang gambar dekat bawah saya case tu, I think my internet is a bit lagging. Kalau kamu tengok bawah ni kan, that one the gas inside an enclosed system, that one is what we call the system lah. So dikata kalau positive Q, heat being absorbed into the system. So maksudnya Q ni masuk dalam sistem. Kalau negatif, maksudnya Q going out of the system. Okay, so example it loses the heat ataupun heat transfer out. That one is the meanings of positive Q and negative Q. Delta U represent the change in internal energy. So kalau positive delta U, you will expect that final energy is bigger than the initial energy. So U2 is bigger than U1 kalau dia positif lah. So maksudnya U dia increase. Okay, so change in internal energy kalau positif maksudnya internal energy to increase. And if you guys still remember, U ni directly correlated to the temperature. U increase, T increase. Kalau negative U, it means that Q decrease and T decrease. Kamu ingat tak lagi formula untuk U? Siapa boleh beritahu saya? What is the formula for U? U equals to what?
Q tolak W.
Sorry? Kamu cakap apa?
Q tolak W.
Okay, that one is correct lah. If you are using this formula, first law of thermodynamics, so basically if you want to find data U, you just rearrange this one, Q minus W, correct? Okay. What is the other formula? So from previous chapter, kamu ada belajar pasal internal energy. U sama dengan berapa? Apa? Farah ada cakap something kan? Macam dengar. Yes,
U
correct.
equal to 1/2 FNK tu.
Okay, correct. So nanti orang cakap benda yang sama lah, I think. So U here actually equals to this one from previous chapter, so you might have to use inside this chapter as well. So U is equals to N over 2, sorry, F over 2 and KT. Okay. So if you guys still remember, F over 2 KT represent total kinetic energy. Okay, kalau kamu nak multiply all that one is for one molecule lah. Kalau kamu nak kira untuk semua molecule, you multiply by N. That's why this is the formula lah. Tapi this one is delta U. So maksudnya yang ini minus yang lagi satu lah. T2 minus T1. Okay, for the work. Okay, W here represent the work done by the system. So it means that kalau positive W, gas ni buat kerja. So if this gas is doing work, you will expect that the container to be expanding. Okay. Kalau container expanding, it means that the volume is increased. So positive work means the work done by the system, the volume of the system increase. Kalau negative work, maksudnya work done on the system, contohnya macam ni lah. So dia being pressed, so orang luar yang tekan dia, so that means that the volume is decreased. Okay, any question? Tak ada. You guys faham ke tidak?
So nak tengok slide yang first tadi.
Slide first, this one. Ada nak tanya ke? Tak ada.
Tak ada. Dah tiga, thank you.
Okay. Dah. Okay, so let's try to do one of the question. This one is tutorial question number 7. Can you see the question? Nampak tak?
Nampak je.
In each of the following situations, find the change in internal energy of the system. So dia kata, untuk setiap situasi, cari internal energy of the system. The change in internal energy of system. Kalau change in internal energy of the system, symbol dia apa? What is the symbol?
Delta U.
Yes, delta U. So the question actually want you to find delta U. Very good. So obviously, because this one saya baru ajar first law of thermodynamics, eventually you want to apply this equation lah. Q equals to delta U plus W. Daripada mana dia datang? Daripada atas ni lah. Saya buat tunjuk tadi. Okay. So for question A, dia kata a system, so maksudnya gas tu absorb 2090 joule of heat and at the same time does 400 joule of work. Dia kata absorb 2090 joule of heat and at the same time does 400 joule of work. So if you want to take the information out, you write down the numbers. Okay. Yang 2090 tu dia represent by symbol apa?
Q.
2090 tu apa? Energi apa?
Q.
Q. Okay,
Q.
heat. Okay, good. Tak dengar, sorry. And then yeah, at the same time does 400 joule of work tu?
W.
W. Okay, very good. So you get this one correct. So once you identify the quantity, now you want to identify whether it is positive or negative. Okay. Remember this is a scalar, so you have to identify yourself lah. Kalau system absorb, okay, kita go back ke atas System absorb, Q dia positive or negative?
Positive.
Okay, very good. So you will expect to have a positive Q here. Oops. How about the work? At the same time, does 400 joule of work. Siapa yang buat kerja, sistem ke orang lain? So in this example, dia kata, and at the same time, does 400 joule of work. Kamu rasa siapa yang buat kerja, sistem ke bukan sistem?
System.
System.
Okay, good. Kalau sistem yang buat work, the work done is positive or negative? Kita pergi back balik kita tengok sini. Kalau work done by the system, is it a positive or negative work?
Positive.
Okay, very good.
Positive.
So it's positive. Setiap kali kamu nak jawab pun macam tu lah. And then you just have to substitute back inside the equation. I can rearrange this equation becomes delta U equals to Q minus W. Saya rearrange So it means that my delta U is equals to 2090 minus 400. So if you have like negative, you have to substitute the negative inside there. Okay, the unit is in joule. Okay, you can leave the answer like this, 1690 joule, or you can convert to kilojoule if they ask. If they didn't ask, you just leave it in joule. Kadang-kadang dia suruh. Okay, question B. A system absorbs 1255 joule of heat, and at the same time, 420 joule of work is done on it. Okay, so we have two values, 1255 and 420. Okay, 1255 we can represent with a symbol apa? Heat apa?
Q.
Q kan? Is it positive or negative? Heat
Positive.
being absorbed. Okay, very good. So it's positive Q sebab heat being absorbed. How about the work? Work lah, W lah. Is it positive or negative?
Negative.
Negative sebab apa? Dia kata work is done on the system. Okay. So this one will be negative. Very good. So now you can answer lah. Delta U equals to apa dia? Q minus W. So it will be 1255 minus, remember to put the negative sign to become plus, 1675 joule. Okay. Any question so far?
Okay, sir.
Okay. Okay. Okay, now we move on to the question C. You have 5020 joule of heat is removed from a gas held at a constant volume. Give your answer in kilojoule. Okay, ini dia suruh answer in kilojoule. Okay, tiga-tiga tadi suruh answer in kilojoule. Katakanlah dia suruh, let's say dia suruh yang A tadi tu, the answer will be 1.69 kJ. This one will be 1.68 kilojoule. Okay. Now question C. Dia kata 5020 heat is being removed. Heat is Q lah. Is it positive or negative? Heat being removed.
Negative.
Negative, very good. So you have negative 5020 joule for the Q. And then dia kata gas held at a constant volume. V constant. Okay, yang ni saya belum ajar lagi, tapi cuba kita pergi balik ke atas ni. Okay, if you guys look over here, okay, kalau positive work, it means that the work done by the system and the volume increase. For negative work, work done on the system and the volume decrease. What can you say when you have volume is constant? Kamu rasa apa yang jadi dekat dia punya work? Kalau work tu positif, dia mengembang. Kalau work tu negatif, dia mengecut, compress. Kalau V dia constant, work dia?
Kosong ke sir?
Yeah, zero, very good. Okay, very good. So actually you can represent work ni sebenarnya adalah P delta V. Kalau generally lah. Tapi saya tak tulis lagi sebab nanti kita belajar dekat Thermodynamic Process nanti. So work here equals to 0 because the volume is constant. So basically dia macam kamu tolak objek tapi objek tu tak bergerak kan. So the work done on the object is basically 0. So same case over here lah. If there's no change in volume, it means that work is 0. Remember that this one is very important untuk chapter ni. Selalu pakai macam hidden information. Okay, so delta U again equals to, saya rewrite the equation. It will be Q minus W. So your Q is negative 5020 minus 0 lah. So that one's the answer in joule. If you want to change in kilojoule, 5.02 kilojoule. Okay. If you have negative, just leave the negative like it is. Okay. It means that delta U is negative lah. Final energy is less than the initial one. Okay, so final question. Okay, kalau tak ada soalan, maybe kita boleh pergi ke next question. Question number 8. An ideal gas is compressed isothermally. Okay, the compressing agent does 36 joule of work. How much heat flows from the gas during the compression process? Okay, dia ada sebut pasal isothermal. So isothermal ni actually adalah thermodynamic process punya nama. Ni kita akan belajar this one very soon in the next subtopic. Tapi yang ni boleh jawab lah, tak ada masalah. Kata compressing agent does 36 joule of work. So work is equals to 36 joule. Is it positive or negative? Okay, siapa yang buat kerja? Is it the gas ataupun bukan gas? Itu je soalan kamu nak tanya diri kamu. Who does the work?
Gas.
Okay, yang ni ayat dia memang little bit confusing tapi sebenarnya compressing agent ni maksudnya ada satu benda lain yang compresskan benda ni. Okay, it could be another types of gas tapi maksud dia ada satu agent, ada satu benda yang compresskan gas ni. This is the system. So somebody is compressing the system. So this somebody we call as compressing agent. Okay, it could be gas, it could be a piston, it could be anything lah. So benda ni yang buat kerja. Okay, so the work done actually is on the system. Bukan by, dia on ke atas sistem tu. So positif ke negatif?
Positif.
Are you sure?
Negatif.
Negatif. Negatif sebab apa? Work done on the system. Nanti kamu boleh tengok balik lah. So jangan confuse ni. Dia kadang-kadang dia memang little bit confusing sebab selalunya dia pakai compressing agent ni gas juga. So kamu kena faham lah, dia ada dua jenis gas, satu yang kat luar, satu yang kat dalam. So yang kat dalam tu is the system, yang kat luar tu yang agent dia. Macam mana kamu nak tahu? Sebab nama dia compressing agent. So kalau sistem tu buat kerja, dia akan expand, dia tak akan compress. So compress means dia adalah negatif. Okay, that's another keyword lah. Okay, now back to the equation. You have Q equals to delta U plus W. Dia kata how much heat flow. So soalan ni nak Q. So Q equals to delta U sama dengan berapa? Okay. Isothermal here actually represent that the T is constant. Okay. What can you say about delta U when the T is constant?
0.
Yes, 0. Sebab apa? Sekejap saya tunjuk. So kalau kamu still ingat, delta U is equals to U2 minus U1 ataupun U final tolak U initial kan. Dan U ni equation dia adalah F over 2 and KT. Okay, sekarang saya substitute delta U equals to F over 2 and KT. So dia T2 lah. Minus F over 2 and KT. This one for T1. And K dengan F over 2 tu basically is a constant. Untuk satu type of gas dia ada sekali je lah. So N, K, saya akan factorize T2 minus T1. So kalau T constant, for T constant, it means that T2 is equals to T1. So when T2 minus T1, which is the same number, then delta T is equals to 0, delta U is equals to 0. Okay. So this is another key finding for from the isothermal punya process. Jadi kita akan go through mamukan kot. So 0 minus 36. Dia plus kan, tapi tolak dekat atas tu sebab ada negatif 36 joule. This Q equals to negative 36 joule. Okay, negative here maksudnya adakah heat being released ataupun absorbed? What does this negative mean? Heat release ke absorb?
Release.
Yes. Heat is released. Okay, very good. I think you guys can get the general things to understand here. Okay, moving on to the next subtopic. Ada soalan tak untuk yang 14.1 so far? Okay, kalau tak ada, kita pergi move on. Sebenarnya, chapter ni ada 3 subtopic. 14.1, which is about the ideal gas equation yang tadi kita discuss. And then 14.2 and 14.3. 14.2 and 3 ni is about thermodynamic process. And kita ada 4 benda yang kita kena tahu for thermodynamic process. We have isothermal. Okay. We have apa lagi? Isobaric. Okay. Now we have isoporic. Okay, isoporic ni sometimes they say that this one is isovolumetric. Tapi kalau dia cakap isovolumetric tu memang obvious volume is constant kan. So macam senang sangat, biasa dia pakai isoporic. Adiabatic. Okay. So these 4 process you need to know apa yang constant. Contohnya isothermal, T is constant. Isovolumetric, V is constant. Isobaric, T is constant. Sorry, P is constant. Saya tulis lah. T constant. Isobaric, P constant. This one is V constant. And for adiabatic, you need to understand that this one Q equals to 0. Okay. These four, you need to be able to understand yang apa yang constant dengan dia punya graph. Okay. So these four you need to understand dia punya PV graph. Bentuk PV graph tu macam mana dan apa maksud bila dia constant. Kalau yang work tu, untuk calculation for work yang kita kira ni actually untuk biasanya work yang kita kira ni hanya untuk tiga proses je. Yang adiabatic ni tak ada dalam syllabus kamu untuk calculation for work. But the other three ada. Okay. So work ni kita ada for isothermal, isobaric, and isochoric. Okay, yang these two pakai formula sama. Okay, yang satu ni dia pakai equation lain sikit, dia ada ln. So this one would be nRT ln V2 over V1, or you can use nRT ln P1 over P2. It depends on the information given, and you can use the information. Okay, so this is what you will learn lah untuk the remaining chapter for this one. Calculation dia dekat sini. Okay, yang lain semua more to explanation. Okay, so we go through one by one. We start with the isothermal punya process. Okay, iso here means constant lah. So kalau isothermal maksudnya apa yang constant?
Temperature.
Okay, so here the temperature is constant. Okay, just now kita ada discuss. Kalau isothermal, T constant, apa yang zero? Ingat kita? Baru je kita discuss.
Internal energy.
Yes. Change in internal energy is equals to 0. Sebab apa? Saya ulang balik. So you know that delta U is equals to U2 minus U1. And this U, you can relate directly with the temperature. So I can write that this one equals to F over 2 and K T2 minus T1. Saya skip a few steps because tadi saya dah explain. So when the T is constant, you expect that delta U is equals to 0. Okay, this is the key things that you need to understand. And this thing, the fact that T is constant, it obeys the Boyle's law. This from previous chapter. Boyle's law. And you guys do know that Boyle's law, kalau kita pakai yang triangle tu, PVT, okay, kalau T dia adalah constant, maksudnya PV equals to PV. So you can also write the equation PV equals to PV. Okay, sometimes you want to use this equation as well. Okay, so jangan tiba-tiba hilangkan terus, jangan terlupa pula yang chapter ni dia boleh gabung dengan chapter sebelum ni. Okay, and the most important thing other than this thing is that you have to understand the punya graph of PV. So for this one, the PV graph will look something like this. Okay, biasanya kita label P, and then depends on the given unit. Normally SI unit is in Pascal lah. V in meter cube, Okay, and since you have a constant temperature, so you have one temperature profile. Okay, satu curve ni, I want you guys to understand that this one curve means that the temperature one value. You have one values for temperature untuk satu curve. So this one is T. Kalau ada different temperature, you will expect to have a different curve. Okay, jadi kita tengok kalau dia ada different temperature. So kalau proses tu, let's say dia kata from here to here, kamu kena tengok arrow dia. Macam mana nak tentukan arrow tu, kamu kena baca dia punya ayat dia betul-betul. So katakanlah kamu punya proses sekarang, isothermal process, bergerak daripada atas tu, dia turun bawah, curve. So yang atas ni akan jadi kamu punya P1. Okay, your final position will be your P2. Okay, similarly, this one is your V1 and this one is V2. Okay, kadang-kadang dia suka cari final volume dekat sini. Okay, dia kasih nilai ni, nilai ni, nilai ni. So you can use Boyle's law punya equation and then you can find the V2. Tu senang lah. Alternatively, they might ask you to find the work. Okay, work done actually equals to area under the graph. So area here represent work done. Okay, so kalau curve macam ni and you want to find the area, basically you have to integrate. You have to do the integration. Dia ada dia punya derivation. I think the derivation of the formula in page 25 code, if I'm not mistaken. Let me check. Page 25 for your lecture notes. Yes. Okay, so you can always refer to the page 25 for derivation. Saya tak tunjuk. Because most of the time you just have to use the formula. So the formula that you want to use to find the work here is equals to nRT equals to nRT ln V2 minus V1. Okay, dulu student selalu terconfuse. P1, P2 ke V2, V1 tu mana atas mana bawah, dia selalu confuse. Tapi sekarang you are given the formula sheet, sepatutnya tak ada masalah. Okay, so to calculate the work done, since you cannot simply calculate dia punya apa tu area, you have to do the integration on all. So formula yang ada adalah itu. Okay, ada soalan? Okay tak? Asal teman?
Okay, sir. Sir
Okay.
nak tengok previous slide.
Previous slide. This one? Okay. Apa kamu asyik terkeluar?
Saya salin sebenarnya.
Oh,
Okay dah.
okay. So others, are you guys okay? Lain ada nak tanya apa-apa? Okay, kalau tak ada, kita move to the next process. Okay, the next thermodynamic process is isochoric. Okay, also known as isovolumetric. Dulu dia ada nama lain, which is isometric. Okay, that one kita dah memang tak pakai lah. Isovolumetric we still use. So, as its name suggests, this one is a constant apa ni? Apa yang constant? Kalau isovolumetric, apa? Volume is constant. Very good. Okay, so one of the key thing here, the work done, saya pernah tunjukkan kat atas ni kan. Kalau untuk isothermal, okay, work done there is a little bit different. equation dia berbeza. Sebab apa? Sebab kamu ada curve. Untuk kira area under the curve tu dia kena integrate kan. So satu equation dia pelik sikit. But the other two, you basically have a straight line. Okay. So the work done will be P delta V. Okay, so kamu boleh hafal straight away lah. So work done is equals to P delta V. And since volume is constant, maksudnya work done equals to apa? Zero. Very good. Sebab apa? Sebab P ni sebenarnya adalah V2 minus V1. Kalau V tak berubah, maksudnya V2 and V1 is equal. So I can write the work is equals to 0. So for isobaric ataupun isobaric process, the work done on the system is equals to 0. Okay. And since V is constant, this one actually obey law apa? Ingat lagi tak? Apa? Gay-Lezak. Dia actually obey Gay-Lezak law. Macam mana? Obey Gay-Lezak. So kalau V constant daripada triangle tu, if you guys remember, P, V, T, V is constant, so you expect to have P over T equals to P over T. Okay, so this equation is valid for this process. Okay, and then if you go back to the law of first law of thermodynamics, Q equals to delta U plus W. Since the work done is equals to 0, then you get directly lah, Q is equals to delta U. Okay, remember that. Okay, about the graph lah. For the PV graph, okay, katakan saya punya proses tu bermula daripada sini. Start from there. Okay, dia kata proses tu volume dia adalah constant. So proses tu hanya boleh naik straight line ataupun turun straight line. Here I'm going to draw it as naik straight line. Okay, so this is the isovolumetric punya proses ataupun isobaric lah. So constant volume maksudnya the volume doesn't change throughout the process. Sepatutnya saya lukis betul-betul. So if it is like this, then you expect that you have two values for P and one value for V. Okay, so P1 dekat atas ke kat bawah? Kalau saya nak label.
Atas. Bawah tu.
Okay, P1 dekat bawah sebab itu the starting position. So P1 would be your initial and P2 would be your final. Okay, very good. Okay, so far ada soalan ke tidak? Okay, kalau graf dia macam ni, dia nampak macam tergantung. Macam tu je kan. Okay, kalau kamu nak relate dengan temperature profile tu, I'm gonna paste it over here. Okay, and if you guys still remember, I told you before, yang setiap satu line ni represent satu values for temperature. Yeah. Okay, so maksudnya dekat sini, you will have T1 and T2. T1 tu yang initial lah, yang bawah. And this is your T2. So ada dua temperature. So dekat sini you will see ada dua benda berubah lah. Pressure berubah, temperature also change, which is exactly how Boyle's law, Gay-Lezak ni punya law lah. So here T1 dengan T2 mana lagi besar kamu rasa? Okay, lagi tinggi dia dalam graf PA ni, PV ni, lagi besar value dia. So T2 is actually bigger than T1. Okay. So katakanlah T1 tu adalah 100 Kelvin, you expect that T2 tu more than 100 Kelvin lah, maybe 200 Kelvin or so on. Okay, ada soalan?
Tak ada, sir.
Okay, if there's no question, we go to the isobaric process. Okay, kita dah discuss temperature constant, volume constant. So this one apa yang constant? Pressure constant, very good. So we use small p here. Saya ikut computer nota punya ni lah, symbol. So the pressure is constant. But can you say when the pressure is constant, you can say that work equals to P delta V kan? So tak ada masalah lah, tak ada perubahan pun. So work equals to P delta V. Okay, one more thing saya lupa nak cakap. Kalau kamu perasan, graf kamu straight macam ni kan? Area under the graph kamu sama dengan 0. Sebab apa? Dia tak ada area pun bawah ni. That's why work done is equals to 0. Okay, jadi kita akan tengoklah kenapa P, dia jadi P delta V. Okay, maybe saya will try to case dia punya graph dulu. P against V graph, again Pascal, volume meter cube. Okay, so kalau dia kata dia adalah constant pressure, so it means that the process, for the process you will have a straight line. Tapi tadi kalau tadi horizontal, vertical, this one you will have horizontal. Satu values for P. Oops. And then you expect to have two values for V. Okay, mana satu V1, mana satu V2, it depends on the direction of the process lah. Kalau dia kata dia expand, V1 dia belah kiri ke belah kanan?
Kiri.
Okay, good. V1 will be on the left, V2 will be on the right. So starting the V1, final the V2. Okay, and from here you can see that the area under the graph is actually this one. It's a square. Area sama dengan work. Okay, since this is simply a square, so difference delta V multiply with the P, you will get work. That's why this is the formula that you use. So the work equation ni semuanya actually datang daripada area under the graph. Okay, so macam yang ni dia tak ada area under the graph, so that's why the work is equals to 0. But this one, since you have the area under the graph, then work equals to P delta V. Okay, alternatively you can write the first law of thermodynamics. Kalau kamu ingat, Q equals to delta U plus W. And I can substitute the values of W here. P delta V. Kalau nak masukkan lah. Kalau tak pun tak apa. Okay. Okay, for isobaric, it obeys law apa ni? P constant, law apa?
Charge law.
Obey Charles law. Okay, and again from the triangle itself, PVT, kalau P constant, you will have V over T equals to V over T. Okay, again you expect to have two values for the temperature. So copy this one. Okay, lebih kurang lah sebab. Okay, so again you have T1 and T2. T1 dia kalau ikut arrow tu, T1 dia belah bawah ke belah atas? Guys, T1 bawah atau atas? based from the arrow of the process. Bawah, you can see clearly lah, sebab arrow dia daripada kiri ke kanan. So the T1 will be here and the T2 will be there. Okay, and then as you guys know, T2 bigger than T1 because T2 is located higher than T1. Okay, so kenapa saya selalu tanya kamu mana T1, mana T2, mana P1, mana P2, semua tu sebab that one is very important. I would expect they give you a graph and maybe you have to deduce some information from the graph and you have to calculate. Okay, kalau kamu faham, then shouldn't be a problem. Okay, and then the last process. Okay, and then this one minus the work punya equation. Tak ada equation for work Ada, tapi tak ada dalam syllabus kamu. Okay, adiabatic process. Okay, adiabatic process. Here dia lain sikit lah. Over here it says that no heat transfer into or out of the system. In or out. Okay, and when there's no heat transfer, it means that Q is equals to 0. So the key finding here is Q equals to 0 lah. Kalau Q equals to 0, if you go back to the first law of thermodynamics, Q equals to delta U plus W. Kan? Kalau Q0, this one becomes 0. So it means that your work done is equals to negative delta U. Okay. And you have to remember lah, delta U tu macam mana kita nak kira kan. So delta U, kadang-kadang dia suruh kira, kalau dia suruh kira work untuk adiabatic you might have to use this formula lah. U2 minus U1. Tapi yang kiraan daripada area yang ada graph tu tak ada. Maybe kira daripada sini je lah. Negative F over 2 and KT. T2 factorize, so NK T2 minus T1. Jangan lupa negative sign tu. This equation is not even inside your formula sheet. And dia jarang suruh kira lah. But let's say they ask, then you can use this formula. Okay, and then kalau work delta U negative tu, dia ada dua proses lah. You can relate with two process. Satu adalah cooling process, satu lagi adalah warming. Okay, satu tu adalah expansion, satu tu adalah compression. Tentu maybe kamu boleh relate dekat temperature tu lagi senang kot. So work done tu kalau negative over here, kalau find the answer kamu, kalau find the answer kamu negative, maksudnya this one adalah positive. So maksud positive tu final U is bigger than initial U. It means that during the process, the temperature increase. And so you can say that U is directly proportional to the T. Saya tulis yang tu lah. Jarang lah tanya benda-benda macam ni, tapi saya just sebutnya. So kalau yang the exact opposite, yang cooling tu, boleh bayangkan lah. Okay, now how about the graph, PV graph? Okay, chapter thermodynamics ni paling problem kalau dia gabungkan dia punya proses, which is apa yang biasa dia tanya lah. Kalau satu-satu macam ni biasanya tak ada masalah. Okay, and then calculation most likely they will focus the three main tu lah, isothermal, isobaric and isobaric. Adiabatic most likely they use a concept to explanation for concept. Okay. Okay, so in this case, the line scale, they still have two temperature profile. Dia tak obey Charles Bose ataupun Gale-Z. Okay, maksudnya dia ada dua, semua benda dia berubah. Temperature berubah, pressure berubah, volume pun berubah. Yang Q je equals to 0. So the process will look something like this. Okay, so katakan proses dia ke bawah. So you expect that this will be your P1, this will be your P2. Okay, And this will be your V1, and this will be your V2. And this is your T1, and this is your T2. So you can see that P, V, and T, all the values are changes. Dia berubah. Setiap satu tu berubah. And then it depends on the sign dia tu. Sama ada ke bawah atau ke atas. Kalau dia ke bawah, dia sebenarnya adalah cooling. So maybe I can write. Saya tak nak confuse kamu, tapi saya tak naklah sampai tak cakap. So kalau dia ke bawah macam ni, it's a cooling process. Kalau yang dia ke atas, warming. Tapi dia jarang tanya. Memang jarang tanya about cooling and warming process. But just beritahu je lah kamu. Okay, so far ada soalan? Tak ada, okay. So this is the conclusion. I just draw everything inside one graph, okay. But in your exam, most likely they will give you a process yang sambung menyambung lah. Contohnya asalnya dia ada isobaric. Lepas dia kata proses yang kedua isochloric, turun bawah pula. Lepas dia patah balik ke macam tu lah. Kalau dia patah balik ke tempat asal, the work done is equals to 0. Total work done lah equals to 0. Ataupun kamu berkira satu persatu. Remember, work done tu biasanya disuruh kira untuk yang tiga ni. Adiabatik tu jarang-jarang disuruh kira. Okay, cuba kita tengok examples. Maybe you can try 2 example kot. Okay, question number 10. Dia kata ada 2 moles of an ideal gas expand isothermally. Okay, cuba baca dulu soalannya. Soalan nombor 10. Okay, dah baca belum? Okay, 2 moles of ideal gas expand isothermally. Okay, isothermal maksudnya apa yang constant? Temperature constant. Okay, very good. From 200 cm³ to 800 cm³ at 80 degrees Celsius. Calculate the work done by the gas. So kalau isothermal, work done dia, equation dia yang mana? Work equals to?
NRT
Yes,
ln.
very good. Okay, yang pelik tu lah. Dia ada NRT ln V2 over V1 ataupun NRT ln P1 over P2. So ikut logik kamu, based on the information given yang kamu baca tadi, kamu rasa pakai equation yang V2 ke pakai V ke P? Mana nak pakai? V ya, sebab dia beri dalam volume. So dia kata 2 moles, so maksudnya N dia sama dengan 2 mole. Lepas tu dia kata volume expand from 200 to 800. So your V1 is your initial 200 cm³. Okay, you can convert if you want to. Tapi in this case tak convert pun boleh. Tapi kalau nak sama, kamu convert je lah. Dia tak convert tu tak kisah sebab dia boleh potong kat sini. So this one 200 times 10 negative 6 m³. Negative tu kan, darab 3. Okay, V2 dia pula adalah 800 cm³. This one you can write 800 times 10 negative 6 m³. Temperature is equals to 80 Celsius. You can convert into Kelvin. So this one become berapa? Siapa boleh kira untuk saya? Okay, good. 353.15 Kelvin. Correct? Betul. So you have all the information, just have to substitute inside the formula lah. Work equals to nRT ln V2 over V1. We use this formula. N is equals to 2, R equals to 8.31. Your T must be in SI unit, Kelvin, mesti wajib. And then you have ln V2 over V1. Nampak tak? Kecil kira berapa dapat? Saya betulkan minyak. Okay, how much you got over here? Work done.
8136.65.
Okay, yang lain dapat sama.
Sama sir.
Okay, very good. So this is the answer lah. Just leave it like this. Just senang je kan. Okay, next question. Question number 11. The gas of volume 0.02 meter cube at a pressure of 2 Pascal undergoes isothermal compression. Again, still isothermal. If the final pressure is, okay, what is its volume? Dia kata there are dua condition. Kata volume awal dia 0.02 meter cube, pressure awal dia 2 times 10 to the power 5 Pascal. Isothermal compression means that the T is constant, and then they give you the final pressure P2 sama dengan 4 times 10 to the power 5. They want to find initial final volume. Okay, kamu nak pakai apa ni untuk selesaikan dia?
B1
Okay, very good.
B2.
Very good. So this one, you can see that the T is constant. So kalau dia tanya pasal work, kamu kena pakai equation work lah. Kalau dia tak tanya pasal work, macam yang ni dia kata cari final punya pressure ataupun volume. Di volume. So you have to use the triangle. PVT, T is constant. So you have PV equals to PV. So P1, V1, P2, V2. So you can straight away substitute all the numbers. 2 times 10 to the power 5. 0.02. 4 times 10 to the power 5. V2. Okay. Cancel out this one. 1, 2. V2 equals to 0.01 unit apa ni? Meter cube. Okay, any question?